Dalton's atomic theory drives us to the conclusion that we need a good way to know how many atoms are present in an experiment. But how can we do that if we don't have a machine that measures the number of atoms? Again, Dalton helps us out. He was the first chemist to use the concept of atomic mass. If the mass of each atom is known, then we can figure out how many atoms are present simply by measuring the mass of our sample. In his atomic theory, Dalton said that the atoms of an element all have the same mass. But what distinguishes the elements from one another is that different atoms have different masses. Now, he couldn't put one atom on a balance, and of course, neither can we. But he did know that hydrogen is the lightest element, so he said a hydrogen atom weighs 1 atomic mass unit, or 1 AMU. Actually, the formal name for an AMU today is a Dalton. Carbon weighs 12 times as much, so a carbon atom weighs 12 AMU. Although Dalton's first table of masses wasn't very accurate, the idea that the mass of an element is related to the number of atoms is extraordinarily important. Let's take this a bit further. A carbon atom has a mass 12 times larger than a hydrogen atom. If we were to take 10 hydrogen atoms and 10 carbon atoms, the carbon sample would still have a mass 12 times as large. The point is that no matter how many atoms we choose, if there are equal numbers of hydrogen and carbon atoms, then there is a 1 to 12 mass ratio. Note that if we choose different elements, the numeric ratio would be different, but the concept would still be the same. The concept works another way as well. Imagine if we could take a pile of hydrogen atoms and a pile of carbon atoms, and could put each of them on a balance. Of course, we can't really put a pile of hydrogen atoms on a balance because hydrogen's a gas, but use your imagination. Let's say the pile of hydrogen atoms weighs 1 gram, whereas the pile of carbon atoms weighs 12 grams. If there's a 1 to 12 mass ratio, then there must be equal numbers of atoms. What the chemists in the 1800s realized is that they need a unit of atoms, some standard or reference amount of each element. They had the atomic masses of the elements, so they decided to use the same numbers, and that the standard amount of each element would be that number of grams of each element. So for hydrogen, the standard amount is 1 gram. For carbon, 12 grams, and so forth. This amount, this reference unit of each element, came to be known as the mole, which is Latin for heap or pile. We know that these two samples will have the same number of atoms. It turns out that the number is 6.02 times 10 to the 23rd power. We know this as Avogadro's number, named in honor of one of the pioneers of quantitative chemistry.